everyone, myself Sravanthi, working as an assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today my topic is source language issues in runtime environment. So here I'm going to discuss about what is runtime environment, what are procedures, what is source language, what is activation tree, what is control stack, what are the scope of declarations, what is binding of names. So these are the topics which we are going to discuss over here. So what is runtime environment? So runtime environment is nothing but it is acting like a bridge between the high level and a low level programming language. So for example here, see here I have written one program with a add.c is my program which I have written. So whenever we write a program, it is stored in the hard disk. Whenever we write a program, it is stored in the hard disk. And when we compile this program, it generates add.out is the object code it is generated by the compile time. So when we run this program, it generates, so these it moves it into the RAM memory. Nothing but it generates, this process is nothing but runtime environment. So it is acting like a bridge between the high level programming language and a low level programming language. So what happens in this program? So see here into C is nothing but it is a global declaration which is declared before main, and this is the main program void main, and some statements I have written over here at 10 comma 20. So whenever we see this add function, whenever we see a function call, it directly jumps to the definition where the definition of this program is there. So it comes to this definition and it executes this definition. Once the execution is completed, it moves from this definition to the function call, nothing but where the function is called of this definition. So after going here, if any statements are there further to be executed, it executes it and it completes the program execution. So this is nothing but the add program which we are going to do. So whenever we run this program, it generates add.out, and when we run this program, when we compile, it is generating out object, nothing but .out or .object code, and when we run this program, it generates some memory, nothing but these are the steps that takes place when we run this program. That is nothing but where it is going to be stored, it is going to be stored in RAM, nothing but random access memory. So this is nothing but these add.c and the compile time, all these things are stored in the hard disk. When we run only, then only it is moved to the RAM memory it moves, and these are the process execution process that takes place here. So what is code area? So code area is nothing but memory locations for code. So these are the code which we have written. So all these code is going to be stored in this code area, and nothing but which are determined at compile time. So the next one is static area. So there can be local variables and there can be global variables. So here we are going to allot the locations for static data. So at compile time, when we compile this program at compile time, so the memory will be allocated for it. So that is nothing but the locations for local variables and the global variables will be allocated here in global and static area. So coming to the stack. So stack is nothing but whenever a function is called, so nothing but it generates an activation procedure, activation record or a procedure is going to be created. So nothing but that is moved onto the stack. Whenever a function call is done, nothing but that is moved into the stack. So here in this stack, all these the definition of these activation record will be placed in this stack, and it executes all the statements. Once the execution of these activation record or a procedure is completed, it is popped out from the stack. So it is popped out from the stack. So the stack is used to store the procedures or nothing but the activation records in the stack. So the next, data objects allocated at runtime. When we run this program, the memory is nothing but here when we find a function call, it generally goes to the function definition, and this function definition will be stored, pushed onto the stack, and it executes, and once the execution is completed, then it is popped out from the stack. So coming to here, heap is nothing but other dynamically allocated objects at runtime. So what is here? When we are running this program, or when an activation record is going to be generated, or when a procedure is generated, if in this program, if I am going to have more dynamic memory allocations here, and see we can have malloc, calloc, realloc, malloc, alloc, and realloc. All these things are nothing but the dynamic memory allocations we are going to allot. And when we, in order to free the memory, we are going to use free. So these are nothing but the all the dynamic memory allocations. If in the given program, if I'm going to have more number of dynamic memory allocations, then those things will be stored in here in the heap memory. Heap memory is going to be stored. So based on the program, the static memory may increase or the heap memory may increase. If the program is having more number of dynamic memory allocations like malloc, all those variables are used, then the heap size will be increased. Or else if the stack, all the variables or the program size is depending on the stack normal things, then it will be placed in the stack. So this is about the runtime environment. So here the places of the data objects that can be determined at compile time will be allocated statically. So the static data variables, nothing but whenever we are going to declare a variable with static, then those variables are allocated at compile time. Like integer array variable, arrays are nothing but that are stored statically. So, but the places of some data objects will be allocated at runtime. So, few objects will be allocated at runtime and few objects will be allocated at compile time based on the given program. The allocation and delegation of the data objects can be managed by using the runtime, nothing but by using dynamic memory allocations, which are going to be used in heap. The heap memory is used to allocate and deallocate the memory. So we are going to deallocate the memory by using C. If we are not going to deallocate the memory, the heap will be overhead. Each execution of a procedure is called activation of that procedure. So what does it mean? So whenever a function is called, nothing but one activation record or one procedure is created, nothing but that is moved into the stack. So we are going to call this function call, we are nothing but we are going to call it as a activation record, or we can also call it as procedure. Whenever we are going to have an execution, some body, some statements are there of these function, nothing but one activation record is pushed onto the stack. Once this activation record is completed, it is popped out from the stack. Nothing but the memory, it can be deleted from the memory. So here, a runtime environment is the structure of the target computer. So here in this RAM memory, we are going to have registers and memory, how we are going to manage the memory and how we are going to maintain the information that we are going to do in the execution process. So the next is source language issues. So what are the source language issues? So the runtime environment is going to play a vital role here. So here the various source languages are there. Here we have, so it is acting as the bridge between the high level abstractions provided by the programming language and the low level operations. So it is acting like a bridge between the high level language and the low level language. The runtime environment is acting like a bridge between the high level and a low level language. Each source language introduces its own challenges. So nothing but when we are going to generate a source language, or when we are going to write a C program or any Java program or a C++ program, we will be having different types of challenges like memory management or the binding of the names, the scope of the variable or the lifetime of the variable, and the procedure, whether it is an activation, whether the runtime must address and ensure error-free executions. When I run this program, it should be error-free from the errors. So all these things, all these challenges we are going to face when we are going to introduce a new source language here. So what is a procedure? So a procedure is nothing but here a procedure that associates with an identifier with a statement. A procedure is declared, or procedure definition is a declaration that associates an identifier with a statement. So nothing but every procedure is going to have an identifier and a statement. So what is an identifier? Identifier is nothing but the procedure name. See here the procedure read array is the name of this procedure. So that is nothing but the identifier is nothing but the procedure name. And the statement is nothing but the body of that procedure. Body of that procedure, we are going to call it as a statement. And the statement is nothing but the procedure body. For example, see here procedure read array. Read array is nothing but the identifier or procedure name, and these the statements which are written inside this procedure, nothing but open and closed brackets. So all these things are nothing but the procedure body. We can also call it as statements. So a procedure is consisting of two things, that is nothing but the identifier and the statement. Identifier is nothing but the name of the procedure, and the statement is nothing but the statements of the body of that procedure. So we can also call this procedure as a activation record. Procedure is nothing but we are going to call it as a activation record. So what is the lifetime? What we are going to do by this activation? When a procedure name appears, so with an executable statement, so that is nothing but procedure is going to be called at that point. Suppose see here, main is one program and I have written some a. Let me take read array. Read array. Read array is one function call I'm going to call. Some statements are going to be there. So then main is nothing but it is a function call, nothing but one procedure is called, one activation record is created and it is pushed onto the stack. And the next one is read array is there. So read array is pushed onto the stack, read array is pushed onto the stack, and this is going to be executed at the top. When a procedure name appears, this is the procedure name. When the program execution starts, when the procedure name appears within an executable statement, the procedure is said to be called. So we are going to call this procedure where I am having the definition of this procedure, read array, and then it executes this program. So the lifetime of this program will be within that execution. So nothing but once I complete reading from open brace to end, then this execution is completed and it is deleted from the stack. Nothing but it is popped out from the stack. So a procedure is consisting of identifiers and the statement. What is an activation tree? For everything we are going to have an activation record. Activation record is nothing but when a function is called, we are going to generate an activation record. So activation record is nothing but which is going to be placed onto the stack, and there are 7 variables that we are going to take place when an activation record is going to be generated, like return address, parameters, control link, access link, and actual parameters, and also we can have temporary variables and return address. All these things are going to be stored in the activation record. So which statement is going to be placed and what it is going to be done, that is going to be taken place in the activation record. So coming to here in activation trees, so here we are going to generate it in the form of a tree format. We are going to generate it in the form of a tree format. Each node represents an activation or a procedure. Each node is nothing but, main is one node, nothing but it is going to generate one activation record or a procedure. So activation of a procedure. So the root represents the activation of the main program. So in the main program I am having some statements, and again in the A definition again I am having some B statements, again in B I am having some statements. So main is nothing but acting like a root node. The root represents the activation of the main program. This is nothing but the main program, and the node for A is the parent of the node B. So in the main, I am having A is the activation record I am having. So it is going to be called, and it is the activation record A is going to be executed. Then in this activation record A, B is there. So B is going to be executed. A is there, and then the next one is B. So what it is going to tell? The node of A is the parent of the node B. A is nothing but the parent of which node? Parent of B node. And A is the node, parent of A is the main program. Main is the parent of the A program. B is the B parent is A. So if and only if control flows from activation A to B, from A to B, if there is an activation, then only I can tell that B is the parent of A. B node is the parent of A. So the node for A is to be left of the node for B if and only if the lifetime of A occurs before lifetime of B. So what it is telling you? So when I store these in the stack, so the main is the first statement, it is going to be pushed into the stack, and inside the main there is a. So function call is there, it just going to generate an activation record A, and once the activation record of A is going to be executed, in that A there is a B activation record. So a procedure is called, B procedure is called. So which one is going to be executed now? So the B procedure is going to be executed. After completing this B procedure, then only the A procedure will execute. Once the B procedure, B definition execution completes, then only the A execution completes. After completing the A execution, then only the main program execution completes. Why? Because the stack follows last in first out. The stack follows last in first out. So the first B execution will complete, then only the A will be executed. So what it is telling us, the A lifetime will be there until the B is going to be there. See here, A is left to the node for B if and only if the lifetime of A occurs before the lifetime of B. So before the lifetime of B, A will be there here. So once the B execution is completed, then only A can be executed. So until and unless then the A should be there. So the A lifetime will be there before lifetime of B completes. So control stack. So what is here? So here we are going to store or we are going to keep track of the procedures. So when an activation record is created, nothing but it is pushed into the stack. It is pushed into the stack. Once the activation record is completed, then it is popped out from the stack. So what it is going to tell is here nothing but, so when some the activation records may or may not be popped out from the stack. So nothing but some activation records are going to be there in the stack and that are not going to be executed. So that is nothing but control stack. Here we are going to keep track of the live procedure activations here. So and the activation begins and pop the node when the activation ends. The contents of the control link are related to the root of the activation tree. So why? Because I told the main is linked to the A is linked and A should be executed only when B is executed, and B will be executed if and only if C is executed. If C completes, then only B can complete. If B completes, then only A can complete. So nothing but there is a root path of that one. So in that way, the execution is going to be done. And which are the procedures which are not yet completed that are stored in the control stack. Scope of a declaration. Scope of a declaration is nothing but there are different types of scope declarations are there. Implicit declarations, explicit declarations, and scope of that program or scope of that declaration. So a declaration is nothing but syntactic. We are going to say the declaration may be explicit. If we can say that the declaration is explicit, we can have var I integer. So here it is going to tell that there is a variable I of type integer type. So here in the explicitly we are going to declare an integer I, and that integer I is of type integer data type. So this is nothing but explicit declarations. In the explicit declarations we are going to declare a variable with data type. There may be some implicit declarations are there. So if you are going to give just variable name with I, J, K, L, M, so all this it is assumed that it is of type integer data type. If suppose if we are going to give it as index, then also it is assumed it as integer data type. So nothing but these things are going to be done in Fortran. Not now. Now we are going to use this var I integer type. So the portion of the program of which a declaration applies, we are going to call it as scope of that declaration. Nothing but block of that declaration. If I am declaring here int I of some a function definition, these I is declared inside the definition of A. Once I complete the program execution of A, then these I will be deleted. Nothing but the scope of these variable is within this program only. So that is nothing but scope of that declaration. In that particular portion only that variable can be accessed. If I am writing outside this one I equal to I plus 1, so it will not be executed. Why? Because it tells us that I is not declared. So that is nothing but the scope of the declaration. So the next one is binding of names. So the binding of names is nothing but even if each name is declared once in a program, the same name may denote different data objects. We can denote it with different data objects. So nothing but the storage allocation that holds values. Here it is telling is like environment, and environment is of type name and storage. Environment, name, storage. So we are going to tell here the what type of environment it is. A variable is declared and in which address location it is stored. So that is nothing but name and storage. See here, the term environment refers to an action that maps a name to a storage allocation. Suppose I am writing here int x. Int x equal to some 20 is the variable I have declared. So what it happens? The name of this one is x and a storage. In the memory address, some x0, ff27, some address location, these x variable is stored. So whenever I access this one, it generates the output as x0ff27. Nothing but the storage of it is going to storage location, it is going to be generated. Coming to here state, the term state refers to a function. At that particular storage location, what value is there? in that storage location, what value is there? So that is nothing but term state refers to. So here X is at address location X0FF27. At this address location, I am having the value 20. Now when I give state, it generates the 20 as the output. And when I give environment, it gives the address as X0 some address it is going to be generated. When an environment associates storage location with S and with the name X, X is bound to S, and we can also call it as binding of X. So here we have discussed what is a runtime environment, what are the different ways we can do here. So what are the source language issues we are going to face here? One is the activation tree, activation record, and scope of the declaration. Where what is the scope of that variable, and also binding of names, and then activation trees, and what is a procedure, and what are the where it is stored exactly in the memory, and a given program is stored, what is stored in the stack, and what is stored in the heap, and what is stored in static data. All these things we have discussed over here. Thank you.